Pressurization key. Prior to installation of a pneumatic surface-bonded type dicer boots on the leading edge of the wing, you should A. Remove all paint from the area to be covered by the dicer boot. B. Clean the surface with MEK and apply adhesive to the back of the dicer boot and leading edge of the wing. C. Rough the surface with a mild abrasive. Expel. When installing a surface-bonded dicer boot on an aircraft wing, remove all the paint from the area to which the boot is to be bonded. The metal must be perfectly clean, and the bonding material must be applied in strict accordance with the instructions furnished by the maker of the dicer boots. 2. Which of the following are found in a laminated integral electrically heated windshield system? A. Auto transformer, heat control relay, heat control toggle switch and indicating light. B. Heat control relay, heat control toggle switch, 24-volt DC power supply and indicating light. C. Auto transformer, heat control relay, heat control toggle switch and indicating light. Expel. An aircraft windshield that has an integral heater laminated into the panel uses a 115-volt AC power supply, an auto transformer, a heat control toggle switch, a heat control relay, and indicating lights, but no DC power supply. 3. What is one check for proper operation of a pitot static tube heater after replacement? A. Ammeter reading. B. Voltmeter reading. C. Continuity check of system. Expel. A visual inspection should naturally be made of all of the connections. A check of the ammeter reading when the pitot static tube heater is operating is a final check of the proper installation of the heater. 4. What controls the inflation sequence in a pneumatic dicer boot system? A. Shuttle valve. B. Vacuum pump. C. Distributor valve. Expel. A distributor valve controls the inflation sequence in a pneumatic dicer boot system. 5. What is the source of pressure for inflating dicer boots on reciprocating engine aircraft? A. Vane-type pump. B. Gear-type pump. C. Piston-type pump. Expel. Normally, the air pump used on a reciprocating engine for the inflation of dicer boots is a vane-type pump. 6. Which of the following regulates the vacuum of the air pump to hold the de-icing boots deflated when the pneumatic de-icing system is off? A. Distributor valve. B. Pressure regulator. C. Suction relief valve. XPA. A suction relief valve regulates the vacuum supplied by the air pump to hold the dicer boots deflated when the pneumatic de-icing system is off. 7. What may be used to clean dicer boots? A. Unleaded gasoline or jet fuel. B. Naphtha. C. Soap and water. Expel. Since dicer boots are normally made of rubber, they should be cleaned with mild soap and water. 8. Some aircraft are protected against airframe icing by heating the leading edges of the airfoils and intake ducts. When is this type of anti-ice system usually operated during flight? A. Continuously while the aircraft is in flight. B. In symmetric cycles during icing conditions to remove ice as it accumulates. C. Whenever icing conditions are first encountered or expected to occur. Expel. An anti-icing system is operated in flight when icing conditions are first encountered or when they are expected to occur. The leading edge of the wing is kept warm by a continuous supply of heated air. When the system is designed to dice the leading edge, much hotter air is supplied to the inside of the wing, but for shorter periods of time and in a cyclic sequence. A dicer system allows the ice to accumulate and then breaks it off. 9. Which of the following indications occur during a normal operational check of a pneumatic dicer system? A. relatively steady readings on the pressure gauge and fluctuating readings on the vacuum gauge. B. Fluctuating readings on the pressure gauge and relatively steady readings on the vacuum gauge. C. Pressure and vacuum gauges will fluctuate as the dicer boots inflate and deflate. XPL. A pneumatic dicer system is operating normally when the pressure gauge fluctuates as the various tubes inflate, and the vacuum gauge shows a relatively steady reading as all of the tubes are held deflated. 10. What method is usually employed to control the temperature of an anti-icing system using surface combustion heaters? A. Thermocycling switches. B. Thermostats in the cockpit. C. Heater fuel shut-off valves. XPL. Thermocycling switches control the temperature of an anti-icing system that uses combustion heaters. These switches shut off the fuel to the heater when the temperature is high enough. 11. What is the purpose of the distributor valve in a desing system utilizing dicer boots? A. To equalize the air pressure to the left and right wings. B. To sequence the dicer boots' inflations symmetrically. C. To distribute anti-icing fluid to the dicer boots. XPL. The distributor valve in a dicer system sequences the dicer boot inflation and deflation cycle, so the ice will be removed symmetrically from the aircraft. 12. What is the purpose of the oil separator in the pneumatic dicing system? A. To protect the dicer boots from oil deterioration. B. To remove oil from air exhausted from the dicer boots. C. To prevent an accumulation of oil in the vacuum system. XPL. The oil separator in a pneumatic desing system is located in the exhaust of a wet-type vacuum pump. Oil from the engine is used to lubricate and seal the pump. After passing through the pump, this oil is discharged with the exhaust air. The oil separator removes the oil from the air and returns it to the engine crankcase. Getting rid of this oil before the air reaches the dicer boots helps prevent their deterioration. 13. Where are the heating elements located on most aircraft with electrically heated windshields? A. Laminated in the glass. B. Attached to the glass. C. Inside the windshield frame. XPL. The thermistor-type heat sensors in an electrically heated windshield are laminated into the glass panels. 14. Two possible sources of heat for the operation of a wing thermal anti-icing system are A. First stage of the air cycle turbine and turbo compressor. B. Compressor bleed air and aircraft electrical system. C. Combustion heater and exhaust gases. XPL. Wing thermal anti-icing systems usually use heated bleed air from the turbine engine compressor, but electrically heated elements are also used in some installations. 15. What maintains normal windshield temperature control in an electrically heated windshield system? A. Thermal overheat switches. B. Thermistors. C. Manually controlled rheostat. XPL. Thermistors, a special form of electrical resistor whose resistance is a function of its temperature, are used to control the amount of current used in an electrically heated windshield. 16 arcing in an electrically heated windshield panel usually indicates a breakdown in the A temperature sensing elements. B. Autotransformers. C. Conductive coating. XPL. Arcing inside an electrically heated windshield panel usually indicates a breakdown of the conductive coating through which the current passes. 17. Which of the following connects vacuum to the dicer boots when the system is not in operation to hold the boots tightly against the leading edges in flight? A. Vacuum relief valve. B. Ejector. C. Distributor valve. XPL. A distributor valve in the dicer system directs vacuum to the dicer boots to hold them tightly against the leading edges in flight when they are not needed. 18. How do dicer boots help remove ice accumulations? A. By preventing the formation of ice. B. By breaking up ice formations. C. By allowing only a thin layer of ice to build up. Dicer boots inflate and deflate to break up ice that has formed on the leading edges of the wing and the tail surfaces. 19. Why are the tubes in dicer boots alternately inflated? A. Alternate inflation of dicer boot tubes keeps disturbance of the airflow to a minimum. B. Alternate inflation of dicer boot tubes does not disturb airflow. C. Alternate inflation of dicer boot tubes relieves the load on the air pump. Pneumatic dicer boots are inflated alternately to keep the disturbance of the air over the airfoil to a minimum. 20. What system component aids in the prevention of carburetor icing? A. Alcohol injection nozzle. B. Bleed air valve. C. Air diverter butterfly. XPL. Carburetor icing can be minimized by spraying isopropyl alcohol into the throat of the carburetor and by using heated induction air. 21. Why should a chemical rain repellent not be used on a dry windshield? A. It will etch the glass. B. It will restrict visibility. C. It will cause glass crazing. Expel. If a syrupy chemical rain repellent is sprayed on the windshield of an airplane without a heavy rain striking it, it will smear and restrict visibility through the windshield. 22. What is the principal characteristic of a windshield pneumatic rain removal system? A. An air blast spreads a liquid rain repellent evenly over the windshield that prevents raindrops from clinging to the glass surface. B. An air blast forms a barrier that prevents raindrops from striking the windshield surface. C. A pneumatic rain removal system is simply a mechanical windshield wiper system that is powered by pneumatic system pressure. Expel. A windshield pneumatic rain removal system blows the rain from the windshield with a blast of compressor bleed air, a blast of high-velocity air directed against the outside surface of the windshield, forms a barrier that keeps raindrops from hitting the surface of the windshield. 23. What mixture may be used as a desing fluid to remove frost from an aircraft surface? A. Ethylene glycol and isopropyl alcohol. B. Methyl ethyl ketone and ethylene glycol. C. Naphtha and isopropyl alcohol. XPL. Frost may be removed from an aircraft by spraying it with a desing fluid, which normally contains ethylene glycol and isopropyl alcohol. 24. Which of the following is the best means to use when removing wet snow from an aircraft? A. A brush or a squeegee. B. Hot air. C. Warm water. XPL. Wet snow deposits should be removed from an aircraft with a brush or squeegee. 25. What are three methods of anti-icing aircraft windshields? A. An electric heating element in the windshield, a heated air circulating system, and windshield wipers and anti-icing fluid. B. A blanket-type heating system, an electric heating element in the windshield, and a ribbon-type heating system. C. An electric heating element in the windshield, a heated air circulating system, and a hot water system. XPL. Some aircraft prevent ice formation on the windshield by using a double-panel windshield with warm air blown through the space between the panels. Others use windshield wipers with anti-icing fluid sprayed on. Most modern airplanes use an electrical heater element in the windshield. 26. What icing condition may occur when there is no visible moisture present? A. Injector ice. B. Inlet ice. C. Carburetor ice. XPL. Carburetor ice can form when the outside air temperature is well above freezing and when there is no visible moisture present. Much of the temperature drop that causes carburetor ice comes from the evaporation of the fuel. 27. What should be used to melt the ice in a turbine engine if the compressor is immobile because of ice? A. De-icing fluid. B. Anti-icing fluid. C. Hot air. Expel. Ice should be melted from the inside of a turbine engine by flowing warm air through the engine until all of the rotating parts move freely. 28. What is used as a temperature-sensing element in an electrically heated windshield? A thermocouple. B. Thermistor. C. Thermometer. Expel. Thermistors, a special form of electrical resistor whose resistance is a function of its temperature, are used as temperature sensors in an electrically heated windshield. 1. How is the cabin pressure of an aircraft maintained in flight? A. By controlling the rate of the air flowing into the cabin. B. By inflating the door seals and recirculating the conditioned cabin air. C. By controlling the rate of the air flowing out of the cabin. Explore. Cabin pressure of an aircraft in flight is controlled by controlling the rate at which the air is allowed to leave the cabin. The pressurization air source supplies more air than is needed for the proper cabin pressure, and the cabin altitude controller controls the outflow valves that regulate the amount of air that leaves the cabin. 2. What controls the operation of the cabin pressure regulator? A. Cabin altitude. B. Bleed air pressure. C. Compression air pressure. Expel. The operation of the cabin pressure regulator is determined by the cabin air pressure, or more accurately, by the cabin altitude. 3. The purpose of the dump valve in a pressurized aircraft is to relieve A- all positive pressure from the cabin, B. a negative pressure differential, C. pressure in excess of the maximum differential. XP. The dump valve in a pressurized aircraft relieves all positive pressure from the cabin when the aircraft is on the ground. 4. What test is used to determine the serviceability of an oxygen cylinder? A. Pressure test with manometer. B. Pressure test with nitrogen. C. Pressure test with water. Explore. High-pressure oxygen cylinders must be periodically hydrostatically tested. In this test, they are filled with water and pressurized to 5/3 of their working pressure. 5. How often should standard weight high-pressure oxygen cylinders be hydrostatically tested? A. Every 5 years. B. Every 4 years. C. Every 3 years. Expel. Standard weight oxygen cylinders must be hydrostatically tested every 5 years. Lightweight cylinders must be hydrostatically tested every 3 years. 6. To be eligible for recharging, a DOT-3HT oxygen cylinder must have been hydrostatically tested every 3 years and be retired from service after a 24 years or 4,380 filling cycles. B. 15 years or 10,000 filling cycles. C. 10 years or 5,000 filling cycles. Explore. AC 43.13-1B states the lightweight cylinders must be hydrostatic tested every 3 years and must be retired from service after 24 years or 4,380 pressurizations, whichever occurs first. These cylinders carry an ICC or DOT 3HT1850 classification and must be stamped with the approval after being inspected. 7. Which oxygen system employs a regulator that operates only when the user inhales? A. Continuous flow system. B. Emergency flow system. C. Demand flow system. XPL. When oxygen is delivered only as the user inhales, or on demand, it is known as a demand flow system. During the hold and exhalation periods of breathing, the oxygen supply is stopped. Thus, the duration of the oxygen supply is prolonged as none is wasted. Demand flow systems are used most frequently by the crew on high-performance and air transport category aircraft. 8. The component that determines the pressure level in the cabin is the cabin air pressure A shutoff valve, B safety valve, C outflow valve, expel. The selected cabin altitude is maintained in a pressurized aircraft by the altitude controller modulating, opening or closing as needed, the outflow valve. The safety valve is open when the aircraft is on the ground and is closed in flight, unless the cabin pressure exceeds a preset value. 9. For use in pressurized aircraft, which is generally the least complicated and requires the least maintenance. A. Chemical oxygen generator systems. B. High-pressure oxygen systems. C. Low-pressure oxygen systems. XPL. Chemical oxygen generator systems are used as emergency backup for pressurized aircraft because of their lack of complexity, efficient use of space and weight, and the small amount of maintenance they require. My custom quiz. 10. What is the main cause of contamination in a gaseous oxygen system? A. Moisture. B. Dust. C. Nitrogen. Expel. The main form of contamination of an oxygen system is moisture. Moisture in the system may be due to damp charging equipment and condensation of moisture in the system. 11. How is the cabin pressure of a pressurized aircraft usually controlled? A. By a pressure-sensitive switch that causes the pressurization pump to turn on or off as required. B. By an automatic outflow valve that dumps all the pressure in excess of the amount for which it is set. C. By a pressure-sensitive valve that controls the output pressure of the pressurization pump. XPL cabin pressurization is normally controlled by the cabin pressure regulator and an automatic outflow valve. The outflow valve dumps from the cabin all pressure in excess of that called for by the regulator. 12-on some cabin pressurization systems, pressurization on the ground is restricted by the A main landing gear operated switch. B cabin pressure regulator. C negative pressure relief valve. XPL. When a pressurized aircraft is on the ground with the cabin closed, the safety dump valve is held open by vacuum controlled by the dump solenoid, which is actuated through the landing gear safety or squat switch. As soon as the aircraft is airborne and the weight is off of the landing gear, the squat switch allows the dump solenoid to close the safety dump valve, allowing the cabin to be pressurized. 13. The cabin pressure control setting has a direct influence upon the A outflow valve opening, B pneumatic system pressure, C inflow valve opening. XPR. The cabin pressure controller controls the opening of the outflow valve. 14. What component of a pressurization system prevents the cabin altitude from becoming higher than airplane altitude? A. Cabin rate of descent control. B. Negative pressure relief valve. C. Positive pressure relief valve. XPLE. All pressurized aircraft require some form of negative pressure relief valve. This valve may be incorporated into the outflow valve, or it may be a separate unit. The negative pressure relief valve opens when the outside air pressure is greater than the cabin pressure. In this way, it prevents cabin altitude from ever becoming higher than the aircraft altitude. 15. If the cabin rate of climb is too great, the control should be adjusted to cause the A outflow valve to close slower, B outflow valve to close faster, C cabin compressor speed to decrease. XPLE. If the cabin rate of climb is too great, the outflow valve should be made to close faster to prevent the cabin altitude from changing too rapidly. 16. Which prevents a sudden loss of pressurization in the event that there is a loss of the pressurization source? A. Firewall shutoff valve. B. Cabin pressure outflow valve. C. Delivery air duct check valve. XPL. There is a delivery air duct check valve, or isolation valve, at the discharge side of the air turbine that prevents the sudden loss of pressurization in the event of loss of the pressurization air source. 17. The primary function of the cabin pressurization system outflow valve is to A. Provide protection against overpressurization, B. Maintain the desired cabin pressure, C. Maintain the same cabin air pressure at all altitudes. XPL. The function of the outflow valve in a pressurization system is to control the amount of air that flows out of the cabin to maintain the cabin pressure called for by the pressure controller. 18. An aircraft pressurization cycle is normally considered to be A. One complete series of events or operations that recur regularly, B. One takeoff and one landing, C. When the fuselage reaches its maximum pressure differential one time. XP. A cycle is one complete series of events or operations that recur regularly. An aircraft pressurization cycle consists of a takeoff, scheduled pressurization, scheduled decrease in pressure, and depressurization. 19. Which best describes cabin differential pressure? A. Difference between cabin flight altitude pressure and mean sea level pressure. B. Difference between the ambient and internal air pressure. C. Difference between cabin pressure controller setting and actual cabin pressure. XPL. Cabin differential pressure is the difference between the pressure inside the cabin and the pressure of the outside, or ambient, air. 20 composite oxygen bottles that conform to DOT-E-8162 have a service life of A-5 years or 5,000 filling cycles, whichever occurs first. B. 10 years or 5,000 filling cycles, whichever occurs first. C. 15 years or 10,000 filling cycles, whichever occurs first. XPL composite oxygen cylinders, which are made of an aluminum shell wrapped with Kevlar and conforming to DOTE 8162, must be retired from service after 15 years or 10,000 filling cycles, whichever occurs first. 21. The cabin pressurization modes of operation are A. Isobaric, differential, and maximum differential, B. Differential, unpressurized, and isobaric, C. Ambient, unpressurized, and isobaric. XPL. The operating ranges, modes, in a pressurized aircraft are the unpressurized mode, the isobaric mode, and the differential mode. In the isobaric mode, the pressure inside the cabin remains constant. In the differential mode, a constant difference is maintained between the pressure inside the cabin and the pressure of the outside air. 22-A pressurization controller uses A-bleed air pressure, outside air temperature, and cabin rate of climb. B. Barometric pressure, cabin altitude, and cabin rate of change. C. Cabin rate of climb, bleed air volume, and cabin pressure. XPAR, a pressurization controller, uses cabin altitude for the isobaric control and barometric pressure for the differential range of control. A cabin rate of climb is used to control the rate of pressure change inside the cabin. 23. When an aircraft's oxygen system has developed a leak, the lines and fittings should be A. removed and replaced, B. inspected using a special oxygen system dye-penetrant, C. bubble tested with a special soap solution manufactured specifically for this purpose. XPL. A leak in the plumbing of an oxygen system may be found by applying a solution of a special non-petroleum-based soap to the suspected area. If a leak is present, bubbles will form. 24. If oxygen bottle pressure is allowed to drop below a specified minimum, it may cause A. the pressure reducer to fail, B. the automatic altitude control valve to open, C. Moisture to collect in the bottle. Expel. If an oxygen bottle is allowed to remain empty, it is possible for moisture to collect inside it and cause rust or corrosion. For this reason, the pressure inside oxygen bottles should never be allowed to drop below approximately 50 pounds per square inch. 25. What controls the amount of oxygen delivered to a mask in a continuous flow oxygen system? A. Calibrated orifice. B. Pressure-reducing valve. C. Pilot's regulator. XPL. In the basic continuous flow oxygen system, a calibrated orifice controls the amount of oxygen delivered to the mask. However, a manual or automatic pressure regulator determines the pressure delivered to the orifice. 26. In the diluter demand oxygen regulator, when does the demand valve operate? A. When the diluter control is set at normal. B. When the user demands 100% oxygen. C. When the user breathes. Expel. With a diluter demand oxygen regulator, the demand valve opens each time the wearer of the mask inhales. 27. The primary difference between aviation breathing oxygen and other types of commercially available compressed oxygen is that A. The other types are usually somewhat less than 99.5% pure oxygen. B. Aviation breathing oxygen has had all the water vapor removed. C. Aviation breathing oxygen has a higher percentage of water vapor to help prevent drying of a person's breathing passages and possible dehydration. XPL. Aviators breathing oxygen has all of the water vapor removed from it. 28. What is used in some oxygen systems to change high cylinder pressure to low system pressure? A. Pressure reducer valve. B. Calibrated fixed orifice. C. Diluter demand regulator. XPL. An oxygen pressure reducer valve may be used to change high cylinder pressure to low system pressure. 29. In a high-pressure oxygen system, if the pressure reducer fails, what prevents high-pressure oxygen from entering the system downstream? A. Check valve. B. Pressure relief valve. C. Manifold control valve. XPL. If the pressure reducer valve in an installed high-pressure oxygen system should fail, a pressure relief valve will prevent damage to the system. 30 high-pressure cylinders containing oxygen for aviation use can be identified by their A-green color and the words "breathing oxygen" stenciled in 1-inch white letters, B, yellow color, and the words "aviators breathing." Oxygen stenciled in 1-inch white letters, C, green color, and the words "aviators breathing." Oxygen stenciled in 1-inch white letters. Expel. High-pressure oxygen cylinders used in aircraft should be painted green and should have the words "aviators breathing oxygen" stenciled on them in 1-inch white letters. 31 refer to figure 14. 1 hour after an oxygen system was charged for a leakage check, the oxygen pressure gauge read 460 pounds per square inch at 63 degrees Fahrenheit. 6 hours later, the temperature was 51 degrees Fahrenheit. A 5 psi change is the maximum allowable in a 6-hour period. What pressure gauge readings would be acceptable to remain within the allowable limits? A. 445 to 450 psi. B. 446 to 450 psi. C. 455 to 460 psi. XPL. The pressure at the beginning of the leak test is 460 psi. The temperature drops 12 degrees Fahrenheit. According to the curve, a 12-degree drop will cause a pressure change of 10 pounds per square inch. The pressure in the system with no leakage would be 450 psi. The pressure is allowed to drop only 5 psi. Therefore, the low pressure allowed in the system will be 445 psi. 32. An aircraft oxygen bottle may be considered airworthy if it has been hydrostatically tested and identified A, with the test date, DOT number and serial number stamped on the cylinder near the neck, B, with the DOT number, serial number and manufacturer stamped on the cylinder near the neck, C, with the DOT number and manufacturer stamped on the cylinder near the neck. Expl. An aircraft oxygen bottle cannot be considered airworthy unless it is stamped on the cylinder near the neck with its DOT number, serial number, and the date of its last hydrostatic test. 33. In a gaseous oxygen system, which of the following are vented to blowout plugs in the fuselage skin? A. Pressure relief valves. B. Filler shutoff valves. C. Pressure reducer valves. Expel. Pressure relief valves in a gaseous oxygen system are vented to blow out plugs in the fuselage skin. 34. What is the purpose of pressurizing the aircraft cabin? A. To permit the aircraft to operate in thunderstorms. B. To allow aircraft systems to operate properly. C. To make human flight possible in the hostile environment of the upper atmosphere. Expla. Pressurizing aircraft cabins creates the proper environment for prevention of hypoxia. Pressurizing aircraft cabins permits operation at high altitudes. 35. Oxygen used in aircraft systems. Asterisk, a dash is at least 99.5% pure and is practically water-free. B is at least 99.5% pure and is the same as hospital-quality oxygen. C contains a higher level of water vapor than hospital-quality oxygen. Expl. Oxygen used in aircraft systems is at least 99.5% pure and is practically water-free, while hospital-quality oxygen contains more water vapor than is allowed in aviators breathing oxygen. 36. Oxygen systems in unpressurized aircraft are generally of the A- continuous flow and pressure demand types. B. Pressure demand type only. C. Portable bottle type only. Expl. Oxygen systems in an unpressurized aircraft may use a continuous flow system for the passengers and a diluter demand or a pressure demand system for the flight crew. 37. The purpose of the airflow metering aneroid assembly found in oxygen diluter demand regulators is to A. Regulate airflow in relation to oxygen flow when operating in emergency or diluter demand positions. B. Regulate airflow in relation to cabin altitude when in diluter demand position. C. Automatically put the regulator in emergency position if the demand valve diaphragm ruptures. Expl. The airflow metering aneroid in a diluter demand oxygen regulator regulates the amount of cabin air that is allowed to flow through the regulator in relation to the cabin altitude when the regulator is in the diluter demand position. 38. If a high-pressure oxygen cylinder is to be installed in an airplane, it must meet the specifications of the A aircraft manufacturer or the cylinder manufacturer. B. Department of Transportation. C. National Transportation Safety Board or the standards of compressed gas cylinders. Expl. High-pressure oxygen cylinders installed in an aircraft must meet the specifications of the DOT. 39. Before a high-pressure oxygen cylinder is serviced, it must be the correct type and have been a hydrostatically tested within the proper time interval. Be approved by the National Transportation Safety Board. C. Inspected by a certificated airframe mechanic. Expl. Before high-pressure oxygen cylinders can be serviced, it must be determined that they are of the correct type and that they have been hydrostatically checked for burst strength within the proper time interval. 3. AA oxygen cylinders must be hydrostatically tested to 5/3 of their nominal working pressure every 5 years, and 3 HT cylinders must be tested in the same way every 3 years. The date of the hydrostatic test must be stamped on the bottle near its neck. 40-A contaminated oxygen system is normally purged with *A oxygen, B compressed air, C nitrogen, XPL. If an oxygen system has been opened, it is a good idea to purge it of any air that may be in the lines. Plug masks into all of the outlets, and if diluter or pressure demand regulators are used, place them in the emergency position. Turn the oxygen supply on and allow oxygen to flow through the system for at least 10 minutes. 41. How should you determine the amount of oxygen in a portable, high-pressure cylinder? A. Weigh the cylinder and its contents. B. Read the pressure gauge mounted on the cylinder. C. Measure the pressure at the mask. XPL. The amount of oxygen available in a portable high-pressure oxygen cylinder is indicated by the pressure shown on the pressure gauge mounted on the cylinder. 42. What may be used as a lubricant on oxygen system tapered pipe thread connections? A. Silicone dielectric compound. B. Glycerine. C. Teflon tape. XPL. The only thread lubricant approved for use on tapered pipe thread connections in an aircraft oxygen system is MIL-T-5542, oxygen-compatible thread lubricant. Teflon tape applied to the male threads can be used in place of a thread lubricant. 43-on. Transport category aircraft. What might be an indication of an overpressure event of the aircraft oxygen system? A. The green thermal expansion disc missing. B. The green thermal expansion disc in the cockpit missing. C. The green thermal expansion disc on the oxygen regulator missing. XPL. If the pressure in an oxygen cylinder becomes too great, the safety disc ruptures and the oxygen is vented overboard through a discharge line which is covered with a green discharge indicator. This indicator is on the outside of the aircraft, where it is visible on the pre-flight walk-around inspection. 44. Which of the following are characteristics of a chemical or solid-state oxygen system? A. A volume storage capacity about 3 times that of compressed oxygen and system generators that are inert below 400 degrees Fahrenheit, even under severe impact. B. An adjustable oxygen release rate and a volume storage capacity about 3 times that of compressed oxygen. C. System generators are inert below 400 degrees Fahrenheit, even under severe impact, and a distribution and regulating system similar to gaseous oxygen systems. XPL. Once a chemical or solid-state oxygen system is initiated, it releases oxygen at a predetermined rate, which is not adjustable according to demand. On a volume basis, the storage capacity of oxygen in candles is about 3 times that of compressed gas. The generators of a chemical oxygen system are inert below 400 degrees Fahrenheit, even under severe impact. The distribution and regulating system is self-contained. It consists of a stainless steel cylinder attached to manifolded hose nipples. The nipples contain orifices just small enough to ensure essentially equal flow to all masks. 45-turbine engine air, used for air conditioning and pressurization, is generally called A-compressed air, B, ram air, C, bleed air. XPL. The air taken from a turbine engine for air conditioning and pressurization is normally called compressor bleed air. 46-1 Purpose of a jet pump in a pressurization and air conditioning system is to A. Produce a high pressure for operation of the outflow valve, B. Provide for augmentation of airflow in some areas of the aircraft, C. Assist in the circulation of freon. XPL. A jet pump is essentially a special venturi in a line carrying air from certain areas in an aircraft that need an augmented airflow through them. Jet pumps are often used in the lines that pull air through galleys and toilet areas. A nozzle blows a stream of high-velocity compressor bleed air into the throat of the venturi. This increases the velocity of the air flowing through the venturi and produces a low pressure that pulls air from the compartment to which it is connected.